Alright folks, thanks for joining me tonight. I will be going through part 2 of the restoration of the Lafayette regenerative radio receiver, the Explor-Air. Since we were on last week, I've done a number of things in between. So let me just quickly go through what I did. Now you'll remember from the last, just a second. Oh no, dropped frames, sorry about that. One moment. Okay, sorry folks, I just need to change something because I'm noticing I'm dropping the frames. So we'll get to it in a sec. I hope you've all had a great week. We had a real nice time. We did spend it ourselves. I hope everyone stayed home as much as they could for the holidays. We did send pictures all between my family and my wife's family. Okay, well, let's get right to it. So in between, I did some cleaning, actually quite a bit of cleaning work on the parts. You'll recall that they were just all separated between each other, just all in a bit of a rat's nest connected by all the wires. Since that time, I've taken the radio completely down to the individual parts and then removed all the solder, cleaned them up. So we ended up with a bin of parts like this. Let's just quickly go through and see what we got out of it. Now, I'm just keeping the parts that that are still usable, in good condition. The things like the resistors and capacitors, they're a bit more trouble than they're worth to keep. They're cut rather short, but everything else came out quite nicely. Of course, we kept the speaker, met all those tuning capacitors. And you'll notice I individually, after I cleaned them up and sorted them out, using the parts list that came with the manual, added onto a small snack bag the part number. Now, I didn't group it like they did in the manual. I grouped it according to what you'd end up using. So that main tuning capacitor, for example, has a set of brass standoffs and 632 screws. So I just kept those together in the same bag because they really do all mount at the same time. You don't have to necessarily go strictly by the book on that. In other instances, I grouped, so we have a bag here, was this 10 to 23s. It's those coils right there. Just carefully cleaned up and removed all the existing snipped bits of wire by that tapping method you saw, as well as a little cleaning with alcohol. And bag them together, because again, these are all going to install roughly at the same time into the chassis. But that's not all. We're not just recovering the parts, cleaning them up and putting them back in. We are replacing a number, like I said, the resistors and some of those other capacitors, like these ceramics. We'll be shopping for tonight to replace them. Again, it's because they're a little bit fragile, they're really quite inexpensive, and we may not necessarily want to route it the same way it was done originally. So we'll be replacing those. And then finally, I got some gifts in the mail. I really have to hand it to Mike, who was on the stream last week and who runs the analogdial.com website. He sent me a whole packet of awesome things. So first off, he sent me a complete set of new replacement tubes. So Mike, again, if you're on tonight, thank you so much. And I'll just show some of the other parts you have after I get someone a link to the stream. There we go. All right. So he sent these. Put those aside. He sent, and I know how this happens. So when you're looking for a particular mechanical part, say a specialty screw, other things like that, when you're in order from a distributor, you're not going to just get one or two. You're going to get an entire box worth. And if I were to take a guess, Mike, you probably got them from somewhere like McMaster or something like that. They come in a box of 100. And then there you go. So he sent those, and that's again very kind. I don't have them out. He also sent replacement tube sockets, so this radio should be on its way from this point onward. A couple other things I did was, this is pretty familiar territory to anyone who's worked restoring radios. Often your best bet, without doing a bit of mechanical layout or installing new terminal strips, is to replace the multi-section capacitor in a form that's just like what it had before. Again, you'll see this on a variety of radio restoration websites, how this is handled. Originally with some wax, some really quite hard wax I found, the guts of 3 electrolytic capacitors are stuffed into a wax coated paper can, and those connections are led out to those wires. So I was actually able to save the original wires. They're long enough to do the job again. So there's one there. I think there was one right there. So after we order the parts and get them in, we can restuff this, and then it'll go right into the spot where it belongs in the chassis without having to do a substantial rework. And it also kind of looks nice. It is a really nice way to do it without having to put a new terminal strip and everything else. So we'll save that. Last, and is cleaning the chassis. Look at the shine on that. Now, you'll remember from the last stream that this had this dull, grayish, yellow cast to it. And now it is really, really shining. So I'm going to impart my secret, and I learned this from a fellow by the name of Bob Anderson. He's on YouTube under Banderson TV. His secret is one step. I varied a little bit and did 2-step. So that yellowish cast was from a cadmium plate, which over time and exposure to moisture oxidizes and forms that crust. And then there are some spots where the cadmium plating, looks like in galvanizing, kind of had been corroded through down to the base steel. So we have a point here and here. But it's still, this looks, especially underneath, just like new. Okay, so the trick to that was this liquid rust stain remover. So this is a little different. When I started restoring radios, I used navel jelly, and to be honest, except for all but the most basic corrosion cast. I was always a bit disappointed. This comes out, instead of that pink goop, you get this clear liquid, which I believe is a combination of phosphoric and hydrochloric acid. So beware the warnings on the back. This is serious stuff. And in fact, add to that, you're removing a toxic heavy metal from a surface, so you want to take a number of precautions. What I do is I'll have a waste paper kind of bed that this rests on. I'll wear gloves, maybe even double gloves, and I'll make sure to do it in an area where something splashing is not going to affect it, because you are working with an acid. And then after that, several washings in a really dirty, not the kitchen sink area to clean things up. And then everything, once you're done, bag it up and throw it away responsibly. So in the end, you get down pretty clean. It removed all of the surface grayness and even removed these little spots of rust here and here that I had. So when I get down to that point, I'll come in, and this is really half the secret of doing radio restorations like this well, is having all the right chemicals for the job, understanding the material, and then applying the right methods to get to what you want. The rust stain remover gets you just about there, and then I'll come in. This is not exactly it. This really comes from, like, this is double duty. I have a stainless steel table for a dinner table, but I do find that the mixture of chemical and abrasives in this stainless steel polish brought out this wonderful shine on this chassis, all in one rather short step. In the past, what I've done, I've used a number of things. I've used Brasso, I've used Never Dull wadding polish, it's quite a number of things. And I found the stainless steel polish, whatever combination of abrasive and chemical, it worked extremely well. It's almost like it's new, except for those rust spots. And heck, maybe they had this, maybe there was a flood in the... You can imagine if this was back then, in the mid-60s, there was a water main burst in the storage area for all these, and I could see totally getting this in the box new. And there's one spot remaining there, but that's under control. And then I just did a quick wipe down with a thin oil, and then there we go. That's the chassis, nice, clean, and ready to go. So that's pretty typical work. And one of the nice things about rekitting is that you get down to that chassis level, and you don't get to do that with most restorations where you're working in situ. I also went through and polished and cleaned up some other components. Those brass standoffs for the tuning capacitor came out very nice. This didn't require any substantial tooling. That was a 3M pad to rough it, and more of that stainless steel polish. I probably would use Brasso or Flitz. That would be more appropriate. Not exactly looking for a mirror shine. That did very well, and I didn't have to get more chemicals. In my garage, I have 3 bins worth of all the different chemicals I've ever used over the years to do this work, and they really are the secret of doing this work. One of the secrets of doing this work well. Okay, so what's on the docket today? Oh, let me move that away. All right. So we're going to be shopping for some resistors, capacitors, and some wire. And we have to take care of a couple of other things that are, we just did that. Although if you want to see a demo, let me know in chat. I think I can dig something out from the bench here. We're short, besides the passives and the wire, a couple of other parts. And I've looked around on eBay, other places, and I haven't seen anything turn up yet. So we're going to have to make it. First, these are the main tuning knobs. I really don't think they're original. I also don't see any evidence underneath that they have had any means to mount what is supposed to be on the front panel. We should have a transparent plastic pointer coming off of the knob to actually point at what's on the dial. We don't have those. I've looked around to see what I could get from common distributors like DigiKey and Mauser. I've looked on eBay, and I have seen some options, but nothing I'm really willing to pay that much for. It also gives us an opportunity to work it out ourselves. Now, some folks, they run into a similar issue, and you can make your own if you get the right thin piece of acrylic and cut it out to shape. We can get that, and then you attach it in some way. So what we'll be doing on the stream is I'll run through how I solved the problem using open source software and some new online distributors for laser cut plastic parts. So we should be able to fix our main missing dial pointers. Second, my radio didn't come with an antenna trimmer cap. I think something happened to it, and the original owner replaced the trimmer cap with a big kind of pulled, it looked like a main tuning capacitor from an All-American 5 receiver. It was bolted to the back of the radio, and I don't think it ever worked because it was a dead short. So what I found was that one section of one of these, what's called a polyvaricon, that's a polymer variable capacitor, has a section between these two that comes pretty close to that original tuning capacitor. Again, I looked on eBay for something that looked like what was in the manual, and I couldn't find it. So just quickly, the polyvaricon, for anyone who doesn't know, let me just pull out the tuning cap. We talked a little bit about this the last time. There's some repeating. The variable capacitor, when you use in the context of a radio, is something that through a mechanical change, like rotating a set of meshed plates in between, rotor plates as they called, through a set of stator plates, changes the amount of area exposed between the two. As you turn it this way, there's almost no exposure between the two, just a little bit from the proximity. As you turn it this way, then they mesh together, and then that increases this property called capacitance. If you put a capacitance in parallel with an inductance, this forms what's called an LC circuit, and in fact, LC circuits are the key component for forming basic tune circuits. This circuit is tuned to a particular frequency, and it is that number of what frequency is tuned to is some relationship between the amount of capacitance here and inductance here. Okay, so this one between the plates just has air. It's just an air gap between the two. That's our main tuning capacitor. In the polyvarican, to keep it inexpensive and compact, they don't use air. It's going to be rather hard to see. See if I can bring it in for you. Not so much. Okay, apologies. But in between the plates, which you can see rotating here and here, there are sheets of plastic. And the plastic does a very important function. Here's a plate here, here's a plate here. The capacitance between these plates is going to be proportional to their spacing, their area, and the what's called the dielectric constant of the space in between. If you want more capacitance, you can decrease the spacing between. That gets them closer and closer and closer. You can increase the area. Decreasing the spacing gets more difficult to do past the point you saw in that larger tuning capacitor, because then you have to be much more precise. You have to have a good rigid means to hold those plates parallel. If you get them too close, they might actually start to short. That's what happened with the tuning capacitor that originally came with this radio kind of bolted on. Someone had really taken a whack at it, and now those plates were shorting together. You can increase the area. As you increase the area, the capacitor gets larger and larger and larger, which is fine up to a point. It does get expensive and difficult to sight, and other things start to happen if you make it very large. The last thing you can control is that dielectric constant, given as E. E equals 1 if it's just vacuum, and it's pretty close to 1 for air. But if you put some other material here, that's not going to be 1. That could actually go up to 2, maybe up to 4. So now you've multiplied it without having to change the area and the spacing. It also means if you have something solid here and you have two plates that kind of push up against it, they can't get any closer. So it's a really cheap way to make sure that the plates never get closer than they should. But I think predominantly you're getting the most effect by increasing this here by multiple factors. Instead of being 1, 2 to 4. I don't know what the constant is for that, but plastics are mostly in that range. So, and the last thing is that they are cheap. I think I paid $3 for that, which was, I think, a bit much, but it does the job. And most importantly, I picked this. It's going to be hard to see because you don't have the parts in here anymore. It fits very nicely in that spot. The original part that was here is essentially a modified trimmer cap, and that's not much bigger than the original part was. What bolts in these areas here are those coils. I forgot, I think the A coil, the broadcast coils here, that might be a shortwave coil, but whatever it is, they're parts that are going to go here, so you can't put in a standard even small variable capacitor here. There's just no room. But this fits. However, mounting it is a little more difficult. Those are the two mounting holes that come with it, and they'd work fine. In fact, if I really up against it, I'll just go ahead and use it this way. But here and here, 2 oddball screws, M2.6 screws. which are, I think they're almost universally the reason that they exist is to go with these capacitors. It's the only thing I've ever seen use them. I'm sure there's a bigger story, but that's what I've ever seen. I could drill holes here and here, and then similarly I'll have to drill that in the front panel, but I'd prefer not to. So I'm going to show how I can adapt the original mounting scheme to work here and with this. Okay. Let's get to it. I'm going to just quickly pass through my thoughts when I go shopping for resistors, capacitors, and wire. Some preferences, and then I'll show some of the other cooler things. Okay. So first off, the wire. Most of the wire was 22 gauge, and in the manual they just say green wire, blue wire, yellow wire. Well, I got lucky, and I went to, this is not to say all of us get this benefit, but I happen to have a local electronic shop, and they have these rolls of NTE wire, including 22 gauge solid and then there we go. Each of those rolls, and after these streams are over, I'll post the parts list so you all can see it. That NTE wire that comes on short 50-foot spools is almost exactly all the same diameter. A good 22 gauge tinned wire there. The insulation's not very different. In fact, just a little bit thinner, but not by much. And now I have all the wire colors. So I think, like with Mike, this project is maybe the first time I've had to get solid wire like this. So if you want more, do feel free to ask, because now I have 50 feet and some of these sections are relatively short, and my shop does not sell partial amounts, but it'll work a treat. So usually when you see wire, currently, if you go to a hardware store, or even if you're shopping online, first, that's a problem you will tend to run into, that a lot of that wire is going to come on long lengths. And 50 is already kind of short. It's not typical to see 50. You'll see 100 feet, maybe even 500 feet. You have a spool of 22 gauge red somewhere that came off of a 500-foot roll. I'll have to admit, that part's hard. If you can find a supplier near you, this is one of those things in restoration, is to make a lot of friends so you can pull on their expertise, or maybe even their spare wire, because we all have to make those selections, those choices to get this stuff, and then you end up with a bounty of it forever. So I'm going to have this 50 foot of yellow wire forever. All right, so what if you find stranded wire? Stranded wire is fine, that could work, but solid wire is definitely a preference, as I'm looking for a wire stripper. It's going to get a little loud. Okay. For cases like this, for the most part, unless you're talking about something that's going to move around, let's say you have a chassis that has all the electronics, the speaker is in a different part of the radio. Yeah, you want that to be stranded, because that wire will need to move around. You don't want solid wire because solid wire will fatigue. However, if you're in a chassis, you're not expecting to move that wiring around very much. What you want it to do is to be able to stay put as you're working with it, and especially after you've inserted it into a joint and then bend it over. Oh, there we go. Bend it over. This is an embarrassing one, but okay. So let's say that goes to the rest of the chassis. That wire is not going to move really, because it's really tied into something else you have further in the radio. You can go in. You can be relatively sure during the time you're coming in with the soldering iron that wire is going to stay put, because you really need the joint to stay put while the solder is cooling back down. If the wire moves around a bit, you can get what's called a cold solder joint. That's where instead of being this smooth, continuous weld, so it's not really a weld, but joint between this metal here and that metal there, there's these micro fissions and fractures. And a bed of air too, if it's really quite egregious, that forms a very weak electrical joint. And over time, heat, current, if it's a part in the power supply circuit, that joint can fail, and then mysteriously the radio is not going to work very well. So you will often see in many radios that they've used solid wire, as they did here. Not strictly. Some of the components really do need to have either more wire that can be borne by something you want to be able to bend with. Say if it's something that's high current, say on a transformer for instance, that current needs a fat wire, especially if you're running something like the filament. But the fatter you make a solid piece of wire, the more it's like bending a piece of tubing. It's really hard to do, and it's actually most likely to fracture. So past this thin 22 gauge, it will tend to go stranded. You'll likely see that more in the power supply circuits. I've got that radio wire forever now. Okay. Good. So let's go shopping. There's a number of sources I go. Sometimes if I'm doing a piece of modern test equipment, I'll pick DigiKey or Mauser, and I'll get modern parts. But we're doing a vintage radio, so there's very specific parts we're looking for. Here we're again looking to replace the resistors and capacitors with modern equivalents. Okay. Up on the screen we have my parts list. So I went through the manual and put together this Excel spreadsheet listing all the parts. What do we have originally from the radio, and what do we need to get? Top of the list is a lot of these resistors and capacitors. Again, it's not to say that anything was specifically wrong with them, but they were already installed, the wires were short, and they do have to be replaced. Many of those were fairly low for in power rating, 0.5 watt. Carbon composition, with some exceptions. We do have a 1 watt somewhere in the power supply circuit, and then we have a filament dropping resistor, so a 200 ohm, 10 watt. I have the part number given. I have the part numbers given from original, so as they come in, I can put them in similar snack bags into the kit shoebox. I'm looking, so a lot of these carbon composition wire rounds we can replace with like components for the most part. We could upgrade them to different types. I think I'll be more, what can I get from one or two vendors so I don't just eat it in shipping costs. Below that I have the capacitors, and they're kind of two types roughly. We have smaller values, 100, 470, 270 picofarads, 390, 750, and we have some of the larger values, not by much, but somewhat larger, 0.01 microfarad, 0.005 microfarad. And then finally the last group, the electrolytic. These are, let's see, we have the 30, 30, 30. That was given as one part. And then we have the 1241, which is used for decoupling in the I/O output stage. There's quite a bit of literature, websites, knowledge about selecting the right components for the task. It'll tend to be that you'll, for the most part, be okay with either getting a carbon composition, which are still made, although I would say I think they're still made, but for some specialty applications, for folks who want to make their circuits be exactly like they were originally built. This didn't used to be as big an option in the past, or that you'd be using new old stock, but now there's newly manufactured carbon composition. But for kind of non-critical applications, I'm pretty sure this radio is one of them. We don't necessarily have to pick exactly the same kind. So the current type of carbon resistor that's used is a carbon film. If we wanted to, and there was enough, we could also do a metal film. I've done that in other applications where the carbon composition's in a place where it's going to see a lot of temperature variation. If you replace it with a metal film, it has a lower what's called temperature coefficient, so it should vary its value less. I'm thinking of a Heathkit radio transceiver actually that packed in a lot of carbon compositions on PC boards with vacuum tubes installed that saw a lot of temperature cycling. Replacing those with metal films made that radio work much better. I don't think we have to care about that too much because the radio has the tubes on the top and the parts on the bottom. Not too bad. Okay, I'm just kind of zooming through most of the other parts we already have or already gotten. I'll have to get a line cord to replace the existing one. And there's a bit of hardware here. I briefly went into it. I won't be able to play the video tonight. However, I found that the 440 and 632 screws that are originally used in the radio, if you go to like an Ace Hardware, they'll often, at least in the New England area, they have these bins by Midwest products, and those screws, internal toothed lock washers, those nuts are exactly the same. I mentioned that sometimes if you're getting replacements that especially the nuts can be larger than the original ones used. I found that just the hardware store variants were great replacements. So all of those I've already purchased at the hardware store. In fact, I have that here. It's all listed as hardware store. Very good. Let's go shopping. So the top supplier for restoration hardware, yeah, actually, yeah, I like that. It's too bad they couldn't use that name. For radio restoration hardware is justradios.com. It's a couple that's in Canada. They've been doing this for at least 10, maybe 15 years. And they supply just about everything you might need, all the common replacement parts for all of these vintage radios. So they have all the capacitors, as well as several different kinds of resistors. kind of going down the list, they have multiple types. But the thing we're going to really look for is the polypropylene and polyester films, which are in the yellow here. Let's go take a look. The cart view is a bit busy. I'll have to admit, this part of shopping at his store is a little bit more challenging. He does have multiple ways to handle that. There is an Excel spreadsheet you can use instead if you're doing quite a few parts. Or you can do the other view, like I mentioned. When I do this work, your selection is pretty much given by the values you're trying to match. So the polypropylene film will tend to be for the smaller values. Bring that up here. So things like as I say, 0.002, 0.005, you get in a polypropylene film. And that voltage rating will oftentimes, with these smaller, simpler radios, be well in excess of what you need. I don't think the ceramics that were used in here were nearly rated up to that high. Well, it may be. But really, this radio does not have very high voltages in it, so it doesn't need that. But even at 630, so the thing you'd be concerned is like, okay, well, more voltage is better, as long as the part is still going to fit, right? If you pick one of these very large types, like let's take a look at this 1600, it'll work. It'll be a little unwieldy, and for all that surface there, you have to be more careful about how you route that. But in other applications, that could work. It's just really big for where you're trying to do, so you have to really think that through. I'm gonna pick the appropriate sized part for the job, and these 630s are going to definitely be a little bit bigger than the ceramic capacitors, but they are certainly much smaller than old paper capacitors. So let me go in. There's quite a few options here. Not too bad. Oh, I don't want to show my PayPal. Sorry. All right, so that's one vendor. My recommendation would be to go with these axial types. Although certainly in other cases, and I know some other restorers would go this way, you'll see these other types also made of similar materials, either with polypropylene and polyester, again dependent on value. If you're doing a lot of connections to terminal strips, if you pick one of those axial parts, then you have to bend the leads back over to make a connection what's on a strip. What you really want to do is, if you have to make all these connections on a terminal strip, is to pick one of those what's called a radial type, where the leads come out the bottom side like this. So you don't have to have these flying leads, the part's unsupported. You can get it fairly close to this strip and be able to make the connections cleanly and not have excess lead floating or worry about the parts flopping over. And that's just a matter of going through and understanding what your install application is. So hopefully you've taken videos and photos as you're disassembling something, and you see which ones are better suited to the axial, where you're routing a part from one point to the next with a run of several inches, or the other positions where you have connections all go to a terminal strip, and those radial types will work much better for that job. In fact, probably much better than the original parts, especially if you're working with something that originally had paper capacitors. The less going in and adding heat shrink or sleeving that you necessarily have to do, the better. The better that a part is supported, the better the circuit should work, because it's not going to vary because of being knocked, or the more physically constrained all the parts are, the better it's going to go for you. So that's a quick view of the capacitors. I often use the cart view and just quickly go through and pick my parts depending on where they're going and what they're doing. So let's take a look at resistors. So since I started shopping with this company, he now has quite a few options, especially of these carbon composition resistors. So carbon composition is where there's a slug of carbon-filled material that's compressed into a nugget, and I think they're copper and tin plated steel leads are installed on either end of that material. Yeah, that's it. The resistance material, insulation material, and lead wires are all hot molded together at the same time into one solid integrated resistor. Not bad. Most parts today, so carbon composition's got that slug of conductive material. What you'll typically see in today's resistors, if you're still looking at things that are leaded, or otherwise termed as through-hole, they have carbon film. So there's a body that's non-conductive, and they coat a film of carbon material, and by controlling how that film is applied, they get the desired resistance. I also wonder whether there's also some sort of sorting action they do too. Like they make a bunch and then they sort them a bit, and then they label them after they know. So I don't know, but this is quite popular for putting in like parts. So the one thing you'll know is if the radio was decent enough when it was originally designed and used these carbon compositions, it should, for the most part, as long as the quality of the new carbon composition resistor is the same or better, then the circuit should work about the same. Where people used to get into trouble was that these carbon composition resistors, they over decades did not, at the higher values, did not hold their value. If it was something in the hundreds of kiloohms to megohms of resistance, and they sat in a dank basement for decades, and you pull them out, they may not be what's on the tin, even with the generally sloppy 10% tolerance that they were made to. And at the time, we did not have many manufacturers still making these resistors. You had to order hundreds, so you're often pulling, or if you're ordering on eBay, getting old stuff that was hanging around somewhere. Goodness knows where. Was it a climate-controlled environment, or was it a dank basement? I think I did an experiment a long time ago. I think I found half the resistors for 1 meg were where they were supposed to be. But now we don't have to worry about that, because a lot of folks are very interested in this type. They should work well for a simple application like this, and we could do that. You can see they're premium, so I guess that's going to mean they're going to cost more money. But he's got a number of options. They're not the only option. There's a period of time, and I think it's still the case, that many circuits you can go in and replace them with metal oxide or metal film. Metal oxide's a great resistor for anything you know that's going to be high power, because it is much more suitable to dissipating that heat. And in fact, you can see they're stable, reliable, and flame proof. like that, especially if you're working in one of those high dissipation resistors that goes in the power supply circuit or in the filament. They're going to get hot, and you want them to actually hold their value over their entire operating range. Because really, that operating range going all the way up to 155C, that heat's going to come from it doing its job, dropping voltage, or acting as part of the, well, it's still dropping voltage, part of the filter in a power supply. So what I'll be ordering, and I'll be doing this off screen because I do want to get to other points, but metal oxide resistors for something like that filament drop, it's not a bad choice. You'll also see metal film resistors. Metal film ones are typically selected for their very low temperature coefficient of resistance and tolerance. So if I was working on a meter circuit or something that, I say, some sort of oscillator that depended on something with low drift in the circuit, this is the resistor to pick. It also comes in a very robust half-watt body, and the like. They can tend to be more pricey, and putting in a 1% resistor in a circuit that was perfectly fine at 10%, it's not necessary. Maybe you want in some areas to improve the temperature coefficient, which is good. So temperature coefficient is how much does the resistance change for every degree C up or down from where it's rated is. So let's say it's rated at 20 C, it's going to give me 1 kilo ohm resistance. If it goes up by a degree C, it's only going to go up by 50 parts from that, and then similarly below. So that 50 parts is in contrast to, this one doesn't have it listed. Let's go up to that carbon composition. I think I saw, okay, we'll do the metal oxide. 350 parts per million. So quite a bit of change, which is fine. I mean, in those circuits, these are still relatively small changes. They're not going to change the behavior of the circuit. Say if I need a replacement part for a vacuum tube voltmeter, I may really want that. And in fact, I may actually need better than 1%. I may want something like 0.5% with a very low temperature coefficient, although 50 is pretty low. And then finally we have the power resistor. So that original one from the radio is part of the filament drop circuit. This is one of these internally. It's wire wound. There's literally a wire, nichrome wire that is wound like a coil on a ceramic form, and then it's encased in a rectangular ceramic shell, and is able to handle a lot of heat, a lot of power dissipation. You have 5-watt resistors and 10-watt resistors, and that wire winding has to be factored in. You don't want to use this where there's any high frequency signals expected to pass through, because that wire will actually look very much like an inductor. But if it's just 120 AC going through, like that filament line, then that inductance is negligible, and you can use that part. So just radios is where I tend to do all my shopping, and I'll think about each part. Where is it going? I also try to select to keep things similar. I don't want to go throwing in a handful of metal film resistors and then a handful of carbon composition unless there's a really good reason to do so. And typically, if it didn't have that before, or you're not specifically trying to fix a problem, there's no sense to change it very much. So that's one supplier, and they the prices are decent, but they're not the only ones. You can also buy on eBay. It's a little bit more difficult, but I'll tend to go there for special parts like tube sockets and things like that. But one I've used since I started doing this in 1996 was, and still is, Antique Electronics Supply. So you're going to find a lot of very similar parts, and it's actually more complete if you're trying to, so if you're doing a new design, say if I just literally had the chassis and the front panel, I can get almost everything else from this company. But let's look specifically what we need for the radio. So they have very similar parts. So here they have these tubular axial polymer capacitors and a wide range of values. And I think in many cases they're slightly cheaper than just radios, but they're not bad. So you'll see the similar for that. You'll see it for resistors. So let's do resistors. Come on, you can do it. There you go. All right. And we see there's a wide range. They have carbon film, like I mentioned, metal film. That would be for precision. In fact, you see that right there. Metal film, 1% tolerance. They don't have too much detail, although these details don't talk as much about voltage ratings or tolerances. And they also have some things. So you can, if you got really into it where you needed to really price down to a certain point, these resistors here are a bit more expensive. The capacitors in some cases are cheaper. But really the value is, where's the shipping and handling going to go? So if I needed that and I need a tube socket, well, Just Radios I don't think has tube sockets. Let me take a look. Maybe it's changed. I don't think so. Now it's pretty much components. Yeah. Belts and things. If I wanted tube sockets, well, now I've got a whole range here. So there's a 9-pin to replace that 12AT7 socket, which I don't have to. Mike, again, thanks. You sent me replacements. I wouldn't be surprised if they came from Belton. They look kind of, it looks just about the same. Yeah. You can get that there too. And they have everything you'd need if you're building tube amplifiers. They actually also have vacuum tubes. When I started with them, they had just about every type. Let me think of some oddball type, like maybe a 38 HK7. I don't know. I think that's the right for like some weird TV damper compactron sort of thing. No? Okay. Let's go. How old? Let me see. Let's do this. Let's find like a I don't know, a 1D4? Just trying to think of any crazy old tube. It used to be that they had a substantial new old stock or used tube stock. Maybe I'm just picking the wrong types. But there are a number of other vendors that do make or do provide new old stock tubes. You can also get them on eBay. That's going to be a bit overpriced. What I'm trying to do is find a supplier where I can get most of the stuff. So I need the resistors, capacitors, tube sockets. I need a line cord. So cord. Go with that. And Antique Electronic Supply at tubesandmore.com. has plenty of options. So with these old chassis rears, I really do want to pick something polarized so that I know that, oh great, look at that. It's brown, it's polarized, so I'll know that one side, which side is going to be hot, which side is neutral, and it comes in the original brown color. And how much? $239. It's not a bad price. I actually went to my local electronics store. They didn't have polarized plugs because a lot of modern electronics does not require that. They'll have an internal supply that has a different safety scheme that doesn't need that. And also the hardware store has line cord. They have what's called lamp cord. You can get that, and you can get a separate installable plug. I found it, at least in my Ace hardware, I couldn't get one that had polarization, and actually just looked nice. It didn't look very nice at all. I wanted something molded. That looks great. I'll spare you the tails, but what I will do on the when the stream goes up after the end of this is to make my sheet, which is a Google sheet, available, and you can feel free to use that for your own work on this radio. Okay, so this is my thoughts on shopping for parts, but I still have those two big problems to solve. How do I handle the missing dial pointer and mounting of the polyvaricant capacitor? Let me show you what I came up with. I'll start with the dial pointer. So I'm using a tool called FreeCAD. It's a if you're familiar in the engineering world, there's these big tools for parametric design called SolidWorks, Creo, and the like. Well, FreeCAD has a lot of that same mechanical design capability, but it's available as a free and open source tool. I have FreeCAD version 0.18 going here. And in the sketcher view, I have done a quick sketch of what this might be. Let me actually go to the bench and sketch out what that is, what my thoughts are on this. So the knob I have doesn't really have allowances for mounting something onto it. And again, I searched on eBay and I didn't find two, because both the tuning knobs, the band spread and the main, are like this. I didn't find anything that I was either willing to pay. $25 seemed a bit much, or really was the same dimension as what I need for the dials. So the thought I had is that I do want some sort of thin plastic thing that comes from here. Yeah. And it'll have to have some allowance for the shaft to go through there, like that. And then it's going to have some length, and at that end it's going to have a finer point like that. Let me just shape that out. It could be like that, something like that. So something that looks like a flipper in a pinball machine. And then later on I can scribe a thin line, which I can then fill in with a bit of red paint, and then I have my dial. And I'm sure everyone who's run into the problem, this is what they end up doing. They'll get some thin piece of plastic. We've seen that sort of packaging, and it's Christmas is coming, so we're going to have a lot of that kind of packaging out there. You can take a pair of scissors and cut it to dimension, and it'll do pretty good. What I was really interested, though, is that at some point in the future, I'm going to have problems that are more complicated. I'll have parts that need to have more features on them. So as much as I can use a simpler project like this to learn how to do something more complicated in the future, I think that's a worthwhile investment. If I was rushed for time, I would totally go do that. I'd wait a little bit, get some of that clear plastic like you have for boxes for dolls and trucks and things like that, and just cut it up. I don't have to here if I don't want to. Okay, so something like that. We know that this is where I reach into my bag of tricks again. I'll have to have some sort of width here. There's going to be some radius there. Let me see. Okay. Actually, yeah. I already did this drawing. So I know that I have some diameter here. It was about 1 1/8 inch. If I kind of consider that there's 2 circles with some separation in between, that was 1 3/4 inch separated, and the diameter up here was about 1/4 inch. And that fit onto the dial pretty nicely. Yeah, not too bad if you look at that. All right, go back to my big drawing. That doesn't sort out the last bit. How do I mount it? So I got a couple of things. One is I love this material called it's made by 3M VHB. This is a general class of very high bond adhesive material. It's usually made as a double-sided tape, and you can get this to stick a lot of different materials to other materials. And in fact, I've heard that this is used to stick body panels together on buses. I've used it in my old house to put up decorative, you know, when you have a window like this in a door, and you want to have a little short curtain rod that goes between here and here. I really didn't want to pound any nails, so I used little bits of VHB at the ends, and then I got my curtains like that. That was nice. Anyway, so I could use VHB, and I could coat that material here, and that would stick it on. That's one idea. Or I could come in with 2 brass standoffs here and here, and I could fill these open areas in epoxy. So inside there's this annular space. So this area here is taken up, and this is where the shaft goes, and then there's another one here. So like that. So that's also no-go. I could put a tall brass standoff here and here, and then fill these areas with epoxy. So now I've just modified my existing knob to be able to mount things to. So I fill that with epoxy there as well. And if it's high enough, I can just simply add 2 holes. Let's see. Yeah, maybe here and here. Not exactly, but okay. I can add 2 holes, and then this thing bolts on. That's a thought. I'm kind of steering towards the VHB. It's simpler, plus if I do the thing with the standoffs, then those screws can stand a bit proud. So if you're looking at it at the edge like this is the knob. Let's see, that's the flutes like that. So those internally, those standoffs are here and here, and then I have my dial pointer going here. If I put a screw like that, then that means that the knob has to be pushed out. So here's the shaft coming out of the panel. There's the panel, right? There's my pointer. There's the shaft. There's the knob. And that might work. I mean, it could be. I can certainly try the VHB that's simpler. That's just a bit of double stick tape that's really high bond. Just prepare it with alcohol and just see if I like it. And if I like it, maybe try this out. Okay. That's the thought. Let's see how it turned out on the tool. Very good. So we're in sketch view right now. We see a shape. Let me close that out. There we go. So how you would go do this is you can, let me start something new as an example. We'll go and do a sketcher. All right. So apologies for this. Okay. We'll create a new sketch. We'll pick the XY plane for orientation. And now we're in the sketch view. So along the top, we have a number of shape generating tools. We'll start by making a circle. So pick the center right there. Oh, that's rotating. That's not what I wanted. Create a circle. Okay. Okay, so what I'm getting is a little bit of funniness with the tool. So apologies for that. Okay. Okay. So one thing you have to deal with is with these free tools that are, so you see that version is not even at 1. That means it's not quite at a major level of maturity. So occasionally you're going to get these instances where the tool just acts funny. So what should happen if I open a new sketch is that I can go in and start drawing new circles and squares and things like that, and then show you how to, you see these dimensions? They're actually what's called constraints. So when I did this, I didn't draw a circle and then say, oh, this circle, specifically as I'm drawing the circle, state it to be whatever dimension it is. But rather, you roughly draw the design so you have all the closed shapes you expect, and then you come in and add what's called constraints. And you add constraints until essentially the design has to be what you call out to be. This is, I believe, what's called parametric design. But instead of literally drawing a line that is 43.0378 millimeters, that's not what I did. What I actually did was I drew 3 closed circles. The small one in the middle, the larger one that the kind of butt end of the dial was done at, as well as the small one at the end. I then connected by tangent 2 lines, and then I started filling constraints. The inner circle and the outer circle have to be what's given as, it's all in millimeters, but what is the dimension I had? Something like 1 3/4 inches? No, 1 3/4, yeah, that's right. And then added constraints. That the inner circle has to be some fraction more than 1/4 inch, and then from there and there and there. And as you build those, you'll actually see those add to this constraint list on the left side. So this design here has 15 constraints. Some of them are that the center of these 2 circles on the bottom are coincident to the origin. Some of them have to do with this line is tangent to the circle, and other ones have to do with specific lengths. As you build up enough of these constraints, at the point that there's enough to completely specify design, then you can call your sketch complete. It'll actually turn the sketch a different color from a kind of gray to green, letting you know that the sketch is done. When you've done that, you can then go into part design. Okay. You can go to part design and add that last bit. So we just have a shape in space on an XY plane that has no thickness. Very quickly, when you move it over from the sketcher to part design, all I really have done here is extrude it to some thickness, which is the thickness of, I think this is a 16th inch piece of plastic that I'm representing here. And then we have a complete 3D design. So this is a nice exercise, but if I was just to take a piece of plastic and cut it, what I would do is I would print it out 1-to-1 and then lay it on top, do scribe lines, use a fine point marker, and then I can use this as a pattern. What I've done with this, and we're going to find out next week how well it turns out, it should come in on Wednesday, was that I went to a company called, I actually was originally looking at a company called Big Blue Sock, although their prices were not very good. I went to a company called Ponoko. Let me see if I can pull that up. So Ponoko does laser cutting at a fairly good price. So let me see about exporting this design so you can see it, and let me go to the vendor. We can give that a shot and see how that goes. All right, there we go. So I just need to export a DXF from this design, so let me just do that. That's happening off screen for you. All I'm just doing is making a, it's an speech already. Sorry. Okay. It wants me to sign in. All right. Apologies, I don't want to sign in on this stream, so that was a bit of a miscalculation. But I'll say that for this design, which is a appropriate size dial, I ordered 5, and that's being produced at $4.20 to get 5 of those cut of a thin 1/16 inch sheet of acrylic. That shipping and handling is $10.60, so for all of $14.70, I'll have 2 replacement dial pointers and some extras, and I'll make those available at the end of the project. Let me go back to the dial pointer. I think this really opens up a number of really nice options for doing some restoration work. So this dial here is relatively simple. Again, I could do this by cutting something out, but if I wanted to do something more complex, I'm thinking if you have a dial cover that has to have a particular arrangement of punched holes, and you didn't want to necessarily drill those, or if you had something that needed to bend and you didn't want to necessarily make out of a thin plastic, or if you wanted a diffuser and that has to have a certain thickness for letting the light kind of pipe through the acrylic to the dial markings, then doing this sequence of using a free tool like FreeCAD, and again, that's completely free. It's not freeware, it's open source software, and it's available on Windows, I think Mac, but certainly on Linux. Design a tool parametrically and then produce the design output to give to a vendor. This works well. So that is in production now. That should be delivered on Wednesday, so next stream we'll see those parts. And we'll also certainly see the resistors and capacitors. I've already ordered those in time for next week, where we prepare to and begin to build the radio. The last big task I have on the list is how to adapt that polyvaricon capacitor to the area. I think this is a nice way to do it. We could actually design something in this tool, but I did something a little different this time. Because we have to allow for electrical connections from the rest of the circuit to this polyvaricon capacitor, I made a simple PC board design to do the job. There's almost no circuitry here. It is quite literally just a set of thin pads and surface mount square pads to make the electrical connections. So you see on the upper right, in that large round rect, is the outline of the polyvaricon if it was going to pass through that PC board. The two smaller holes, which are in yellow, are the M2.6 mounting holes, and the large center one is for the actual tuning shaft. The red on the left side, those are the copper pads, which the thin flexible sheet metal pads would solder to, and then it's these that I would tack a wire down from whatever circuitry we're making connection to. I believe we're making a connection to this one here and this one here. So that mounts the polyvaricon to this PC board, which is just represented as a sketch design here. But what's going to mount it to the chassis? That's where these two holes down here come in. So there are existing two mounting holes. One was for a screw, another one was a locating tab that were originally used for the modified trimmer capacitor. Instead, what I'm going to do is use either kind of a combo of a pin and a screw, or maybe just two screws, to hold this PC board through the original pair of mounting holes. What we have in the yellow is the overall outline of the PC board, and there really isn't much more to it. It's a little hard to see in this sketch view, so I'm going to bring up the 3D view of what this board looks like. So here we see in the dark, there's the PC board, and there's nothing on the back. And in fact, we really don't want anything in the back. If you look at the circuit, this antenna trimmer capacitor has to be electrically isolated from the chassis, or bad things will happen. So there's nothing here that's going to cause any shorting. You might think, oh, well, how about the screws that are supposed to go through here? I have a plan for that. Don't worry about that. Okay, just a sec. On the other side, we see that the holes go through. Our capacitor is going to mount on this side. This is the side that faces into the chassis, so that capacitor's here, and the shaft comes out this way, out through the panel. And similarly for nuts, bolts, the nuts would be here, screws go here, and the front panel's here. Then we make electrical connections. The long, thin, let me bring those up on the bench. Those long, thin contacts that come off of this capacitor will tack down to the thin areas here, and all we have to do is just tack wires onto the square pads where needed. I did think about having terminal posts. That still could be done, but I did want to make this thing simple and not have anything go through the board. Okay, so if I needed to, I don't think I need to, but if I needed to, how would I ensure I don't have any problems with the screws here. So if we just put 2 panhead screws, now this surface is not flat and it won't lie correctly in the chassis. Well, when I have these boards fabricated, I'm not just going to buy one, I'm going to buy several. And one thing I can do is I can leave one of those boards unpopulated and open up these holes here and here. So I can also use the VHB tape and stick that board to this board, which makes it a little bit thicker. But it also acts like a spacer of exactly all the same dimensions that allows screws to still go through here, the shaft to go through here, but it gives us space to inset those panheads. And this whole assembly should bolt in very nicely and cleanly and flat up against the chassis. So I have a little paper model of what this looks like on the bench. Let me get my chassis right there. And then there's the paper model, printed right from the CAD tool. So this capacitor goes through here, and I haven't put the 2.6 mounting holes, but I did check in an earlier revision. They do fit. It would go through like that. We're going to have possibly 2 of these boards together, and then that can mount like so. Let's do this. And that goes like so. Not bad. 2 screws, or maybe I'll put a copper pin here that I can solder to the board, and a screw here. It could be either or. We can discover as we get that part in. And that successfully adapts this polyvarican. So what does it look like under the chassis? Well, the design does come close. So we'd likely cut these thin metal leads a little short, and then we would tack our connections here and here. One going to the antenna circuit that was over here with that terminal strip here that goes to another capacitor to the antenna post, and then there's another wire that goes to the I forget, it was the coils of the band switch or something like that, but that'll work very nicely. Okay, so I have a design and it looks good. I've done a check with a paper model, it still looks good. I'm going to run through, just quickly go through that. Oh, I did forget to mention. So what tool did I use to do the design? There's a variety of tools you can use. I find the best open source free tool is KiCad, which is a complete PC board design tool. I didn't come up with it. That allows you to go from schematic capture all the way through to completed layout, the 3D view like you saw. And in fact, the next part is, I think, the coolest thing, because usually when you do a PC board design, there's a step like what I did with the other mechanical design. You have to produce some output file set. And this is a classic thing when you're doing PC board design. You do all the design, there's an internal way it represents that design, it's specific to the tool, but in the end you have to make something called either Gerbers, which is a particular file type that's commonly used for PC board manufacture, or you have to produce drill files. Those are literally callouts for if you have holes, what is the size, where are they located on the board. It's essentially producing an output file set. And those output files are different from the actual design files. Now, there's a number of vendors, including one called Oshpark, that they will work with those output files. All PC board design tools will produce output files. Some of those tools are made to only use one vendor. It's like there's a couple companies that have a tool that only works if you use them to make a board. Let's give this one a shot. This vendor is Oshpark. They're commonly known for making the boards that have the purple color on the masking. It's not the only. I think it's their common color. They do black, but in exchange, it's inexpensive and the turnaround times are pretty good. So that went quickly. I just essentially picked the design file, not an output file, the design file used in KiCad. And then from there, they automatically do the design check to make sure that they actually can produce it. And then they give you a quote. So here we have a simple 2-layer board. Honestly, it's actually just a 1-layer. I mean, yeah, it is a 2-layer board, but it's a basic board like we saw in the design, about 1 1.25 by 1.5. And they're quoting that these 3 boards will cost $9.20. It's not the cheapest place. There are other cheaper vendors, but usually that's done in exchange for time. I think another one's called JLB PCB. I think they would probably quote this at $2 to $3, and I can get that board in a couple of weeks. This board, I should have it shorter. Is it a couple of weeks or even longer? Okay, so they did a design rule check. Let's see what it says. They've looked at it, they've noted it, and then we have one failure. Your project doesn't contain a bottom copper file. Well, that's very easy. There's no bottom copper at all in this design. That's why there's no file. So then they ask, is that okay? If there were major issues, like you came up with a design that is not manufacturable, and the very common ones that you have parts that are overlapping, you have holes that are smaller than they can actually drill, you have parts that are too close to the edge, or you have some weird feature that they can't machine. Because I mean, what they're going to do is they're going to lay up layers of material, copper plated and coated PC board and all that material. They have to actually then at the end go through with a high-speed routing bit to cut it into the shape you've asked them to do. And that's after also drilling the holes as well. But that's our major issue. There's just, they warn the project doesn't have bottom silkscreen. Silkscreen is this white labeling. If you've seen PC boards, there's often labeling that's on some thick ink. That's called silkscreening. We do have one there. It just calls out that there's a C1. That's the one and only capacitor that's there. And then they ask whether it's okay to proceed, and it's okay to proceed. All right, what else would it like from me to proceed? Oh, it wants some details. Okay. Dave at w1euj.com. By the way, Dave at w1euj.com if you want to get in contact with me. That's the email. Okay. So my board's going to look like this on the top side. I like that. That's fine. It's going to look like that in the bottom. The drilled holes are there. Top layer. And then it goes through each separate layer. So what we have is the solder mask layer. So this purplish stuff you see, or if you see a traditional PC board, the green stuff, that's what's called solder mask. It's a thin layer of transparent material that wherever it's put down, the traces are coated. If you see green lines on a PC board, that is copper, which would be yellowish, kind of orangish, but it's been covered over with that transparent green material. So wherever that stuff is, solder is not going to go because there's no open metal contact to be made there. Wherever you're supposed to be making contact, like the pads, which you see here, those are exposed. You won't see that green or here what will be purple coating. Just generally, if you're doing things like automated assembly, you need to have that in place to keep the solder from not going where it was not needed to go. You just really need them on the pads. And then finally, there's the silk screen. There's a little bit of material here, like I mentioned, and that's really all there is. And then we have the options about how we want to have it handled. So, like I said, the base order is $9.20 for 3 boards. Let's see how that changes for 5. They upped it to 6, and okay, $18.40. That's not too bad. I don't need 6 though. Let's go with 3. Can do the super swift. Okay, that ships within 4 to 5 business days, as opposed to I think it's just short of twice as long if you go the traditional service. You can also get that done in flex circuit. We don't want that. You can also get it done with After Dark, which is a really nice looking black material. If you saw some of those PC boards done by, I'm trying to think, there's a QRP group in the 4-state Ozark area. They do really nice kits made of that dark stuff. Very nice. And what would that? Does that not cost more? No, guess not. Cool. All right. So that's one vendor. They're not the only one. You could go to JLB PCB. I'll give that a shot. Okay. Dimensions. What can I upload? All right. Yeah, this vendor I'd have to set an account. I'm not going to do that right now with you guys, but they are another option. They are very cheap. Very cheap. Let's go through this example. 2 layers, 100 by 100 millimeters. Let's see, it's actually more like, let's see, 25, 75. How about that? 50. 5 pieces. That's a standard thickness. 2 layers. Quote now. Let's take a look. $2. Look, it's $2. If you're willing to wait, that is totally fine. They also give you a lot more options and colors too. What do they have for shipping estimates? Take a look. United States. That's not going to let me do that. I have to scroll. Okay. You got me. I have to scroll. Save. All right. Oh yeah, there we go. So their shipping is $6 and the delivery time is 15 to 25 business days. You can get it for 2 plus shipping, but wait a month. I found this is a really great option. I made a quick design some time ago for adapting old CAN capacitors to use the PC board mounting drop type. And I wanted a bunch of those because I commonly run into that problem. So I wanted 50 of these boards made. And I was very confident on the design. So if you're good with that and you want inexpensive parts to do the job, this would be a pretty good option. Okay. Back to the bench. So that's what we have cooking. I have put in the orders like I mentioned. I've done a design to replace the pointer, and we'll see how well that goes. And we have a design for being able to mount this polyvarican in. Those are out and should be in time for next stream. So next stream will be next Sunday at 7 o'clock, and we'll go through all of the list of parts, making sure we have everything in place, taking a look at what they are, and then we will begin to build this radio together. There's a lot of steps, and what I'm going to try to do is kind of intersperse, cut pre-recorded sections of video to speed through some of the common stuff, and then just highlight the special points. So we don't. Although if anyone has an interest in watching someone put this together over the course of, I'm gonna have to guess, an entire evening, I would try it. I really would. I just don't know that I can talk. I haven't talked that much. So before I go, I just want to highlight a couple of other things that I like to do. First, again, my sincere thanks to Mike Simpson, who has that wonderful website, analogdial.com, and I think this radio is going to be part a team achievement. So again, I can't really hardly thank you enough. I'm very appreciative. The second is, I just wanted to show something I had. I got an inexpensive VTVM. That's a vacuum tube voltmeter off of Facebook Marketplace, and I ran into something interesting that you may find the same. Let me just show. This is a vacuum tube. It's very much like you saw from the last stream, but instead of the more typical silver color, let me just pull out one of these other tubes as an example. 12AT7, let's do an example of that. It's missing something. Something has substantially changed in it. Okay. There we go. So one of these tubes should really look like that on top. There's this silvery coating that is completely missing in this one that is present here in the box tube. So a vacuum tube is an interesting beast. You may recall I mentioned that it's a distant cousin of the light bulb. You know how a light bulb is constructed, right? Or a traditional old 19th century to 20th century light bulb. How was that constructed? Not like what the modern is for that. So let's see how well I can, something like this, something like that, and it has those screw threads, and then something like that. It's a little straight. I think it's more like a subway bulb. Like, oh, that looks terrible. That's terrible. Okay, but inside, typically looks like that, right? I mean, I think if you look at it finer, it's actually coils and coils, but you have some wire that's tungsten that's able to handle the temperature. But if you had tungsten and just ran the current through, maybe you've had this happen. I have. Something happened and this cracked. I've had a cracked bulb, and you do that. This tungsten wire turns into this brilliant white smoke, and then the tungsten wire breaks open here, and then there's a bright flash, and then the bulb is lit nevermore. So there's something else that's going on. There's no air here. This is a complete vacuum. It's very, I don't know how high the vacuum is, but it's a vacuum. So there's no gases in here that can react with the tungsten when it's operating at that high temperature. So if you take this shape, and let's just make, what am I drawing? Like a WD-11 tube? Some old tube from the 1920s. They looked like this. And then they had a little curly Q of glass here. That's where you seal it up. This would be hooked up to a vacuum. They'd pull that. And there's the two pins here, here, stuff like that. So internally, and then this is not how they were built, but you'd have that filament of wire like that. And there's the vacuum. And what's going on? Let's just make it a simple diode. Let's say there's literally a plate. So if you look at nomenclature for a tube, there'd be a plate. And this is a very simple one. This is just a rectifier. Plate, filament. Plate. Okay. Literally a plate. If you put a voltage here and here, this is what actually makes this whole effect happen. If you put a positive bias voltage between the filament and this plate, as it's operating at high temperature, you can cause these tiny particles called electrons to flow, and they will tend to flow attracted to that positive plate. And as more here, contact there, a current flows, right? So never mind how that filament is hooked up. So that's like minus plus, something like that. A current will flow, current represented by I. Okay. So that's the very quick basic about how a tube works. The thing of it is that, think what's having to happen in here. You have this high temperature filament in there constantly cooking away, doing this job. And you have all these different surfaces. Light bulb is a little bit simpler. You just have the inside glass surface and that. But then you have, in this one, a lot of metal. And let's say it's more complicated. Let's say I actually had a grid. So you not only have this plate, but you have this is an original one. They actually had a mesh of wire. And they weren't built like this very long. You usually have a cylinder. That's the plate. And then you have this internally, a coil. That's your that's your grid. And then inside is the filament. There's all this material in there. And what happens with materials is that they can bind other elements, particularly gases. And over time, as it gets exposed to heat, those gases will boil off, and then they will start to react and weaken the filament. They will also impact how well this action works. If you've ever seen in any radio repair terminology, things called gassy tubes. That gas is occasionally something that's boiled off. And there's one more path, this really interesting joint between this metal and the glass. There's plenty of opportunities for things to go, but over the decades that vacuum tubes were developed, they got very good with getting tight seals here, as well as in the construction of the right types of metals here, and controlling for exposure and capture of gas here. But even then, there's still some opportunity for gassiness. What they do to help capture that is put down what's called this getter material. So that's where this shininess comes from. It's almost applied like you do for making some types of mirrors. there's a metal, I think it's usually something like cesium, something that's on the periodic chart, stuff that's over here, all those metals that are over here, because they react very nicely to gases. That gets applied. So if you look inside, there's a little ring like so, where they have the metal. They apply a high, I don't know if it's high voltage, but they apply an RF current, and with that RF current, they're literally can cause that metal to evaporate and then coat the inside of the glass. Whenever gas contacts that at any temperature, that gas molecule, or it might be just an atom, is captured. It reacts with the metal and is captured, and it's not going to be free in the tube and interfering with the action. So a good tube should have a nice, clean, consistent layer of this silvery material. Not all of them do. There are some special cases, but for the most part, for these types of receiver audio amplifier tubes, you should see that silvery material. If something goes wrong, the nipple gets cracked, something goes bad with the seals, all of that material will turn from this metallic into the oxide. So I think cesium oxide is kind of a whitish material. Well, here you go. It's turned all white. It's turned translucent. And we see that there's no sign of metallization anywhere. It's all gone. So this tube's gone completely gassy. I think the filament still runs, but both of them, here's the mystery I put to the group. I got this VTVM, it's completely corroded in areas, but not in a consistent way. And I found both tubes, they're clean, although there's some kind of thin corrosion at the pins. But could it be that corrosion, isn't it? Again, it's still very clean. I could say that maybe it's just seen some dust. Could it be that corrosion made its way and caused the seals to fail completely so that it goes gassy like this? Typically, if something goes gassy like that, it's because someone wrenched this tube out and cracked the pin, and the crack is how the gas came in. I've never seen this before. I've heard of weird corrosion when something is located near a lead acid battery, and those sulfuric, is it hydrochloric acid? No, it's sulfuric. Sulfuric acid gases come out, and they can cause this unusual corrosion, maybe including that is covering the bottom of those pins. So this tube's bad. Both tubes in the VTVM are bad, but this one's good. So we'll keep that. So here at the shop, we're preparing for some major renovations. So this radio for us is going to be the biggest work we're going to do for some time. We'll be doing a bunch of particular simulation and more kind of electronics development stuff for a while before we really get set up in a new, with a new shop, possibly a new location. Last thing I want to show is as I was packing up for the painting that's going to happen tomorrow morning, was that I found these things. So these I got off eBay for peanuts, and they're what's called a ferrite transistor cell. So this is kind of that interesting thing where the slight difference in location and team that's working on something comes up with an interesting solution to a problem. So inside each one of these is a core of ferrite material and a number of wires that come through like so, and they're wound through. And then there's the transistor, which I think is some NPN type, yeah, like that. What this core allows you to build, here's a transistor, here's a memory, intended for memory use ferrite core, is a 1-bit storage device. It's a little bit, it's literally 1 bit of magnetic core memory with the active driver here. But it's a little harder to directly correlate that, because literally it's just the individual components. And how does that all work? If you look at designs for how ferrite core memory tends to work, there's the cores, and you have a whole array of them, something like that. Here's your X and Y positions. You have a core here, 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 all the way through, sort of building the memory fabric. And then there's usually some sort of sense lead, and it even gets more complicated than that. There may also be something called inhibit, and that'll go like that. So you have wires going all over the place. And then they will go to interfaces, amplifiers, all that sort of thing, to be able to address and get at the and handle the information stored in that fabric. Well, the Russians who were designing this developed a slightly different theory to meet their needs. I believe these devices here were meant as storage in a calculator. And a great book, which has been translated, talks about how these devices are used. It really gets into detail. Here's the ferrite core and the various theories about how that's used. But then from there, it actually then talks about how do you string these together to build simple memories, logic circuits that have some degree of memory and the like. So we actually get to the ferrite transistor cell. Here's the ferrite core, here's the transistor, plus a small resistance, and then you have a circuit that can operate as a 1-bit memory. What would be nice to do, and certainly on the schedule, is to put that into action. So what do we have? I have 10 of these guys, and wouldn't it be nice to get 8 bits of memory plus some parity going with those? And they come with their own active drivers right there. So with that, thankfully, this has been a shorter one. I hope you've all enjoyed it. Like I said, next Sunday, 7 o'clock, we will have all of the components in-house, and with a combo of pre-recorded video as well as some live streaming. We'll show the assembly of the KT-135 live. If there's any questions, I'm open, but with that, again, I thank you so much for joining me tonight, all the help, and I wish you a great week. All right, Mike, I hope you got something out of that, and everybody else, stay safe. Good night.